Okay, welcome. In this video, what I'm going to be doing is looking at the remainder of what's left of initialization within the Torque engine. So if you remember from the last video, I think what we were doing is we were looking at worker threads. In this video, what we're going to be doing is looking at um, the remainder of what has to be done in the initialization routine after the worker thread pool was initialized. So like last time, I have a variety of breakpoints set. What we're going to be doing is we're going to just step through so that you can kind of see where we're going until we get to that position. The application has been built and started. I have attached it. It's at torque when main here. So if I hit continue, I'll go to torque main, continue. We're in engine init. Remember I said this was for engine initialization. So we're going to continue. We analyze this. We analyze this. Hold on. Analyzed all of this. Continue, 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 continue. Okay, so that was initialized system. If you remember, this was where threads were created, the global thread pool. Two additional threads were created in the module manager, and some console variables were added here. Like you can see timescale, time advance, frame skip, default game, force all main thread. That's interesting. Force all work items to execute on main thread. Neat. So when you're debugging this thing, you can basically force through the console. You can force the application to go into single-threaded mode, so that the items in the worker pool are all executed in the main thread. So I guess that the work distribution is entirely dynamic and scalable. So as long as you have a set number of work items, you can just basically do what needs to be done with them, all in any thread configuration you want. Well, anyway, that's not the point of this video. That was just kind of an epiphany. Um, this is what we have left. We have the global map, the registering of the object global map, the get set active map. Okay, basically you can see it pushes the global map that you just created into the active action map set. Now, I looked over this once or twice so far. I believe action map comes from a sim object. Let's see. Yeah, sim object. Um, and it just holds, like when you register it here, hold on. It's a macro, I believe. Uh, no, it's not. Do, do, do. Oh, no, it's not. This is where it assigns a name. Sorry, I was thinking about uh, the sim object header file where it has a bunch of macros to define a set of things. That was from something I was looking at earlier. No, I guess it just registers this sim object as global action map within the sim data hierarchy, I guess. So basically, it just says in this sim, do this thing. So get active action map set. So this is just referring, or what this is doing is it's pulling a reference to the active action map set, which I guess is kind of maybe default created. Hold on, let me see. Go to definition. Yeah, this is what I was talking about. This is where it was just a bunch of macros. So declare named set. If you go in here, go to definition, you can see that it just creates xturn sim set g set. The pound pound in macros is just a concatenation. So this will put the character g and concatenate it forwardly to the variable set, whatever this is. Let's go back and look at what it was. It was. Wait, hold on, go forward. Declare named set. Yeah, active action map set. So it kind of makes sense. So it'd be G active action map set inline sim set get active action map set, and it would return G active action map set. That's all it does. Remember that macros are executed in the preprocessor, so they can actually generate dynamic code in this particular case based upon data provided. Okay, so let's go ahead and continue this. Let's see, global map. Okay, so it created a new global map sim object. Very cool. Here you can see the file association on line 196. So let's go and let's step into register object. So here it just does that. Remember we were looking at that. Okay, get active action map set. Yeah, this is what I was talking about. So it's just storing this sim object as the global action map set. Makes sense. I mean, we're going to have to study this more in the future when we encounter actually manipulating action maps, I guess. But for right now, it's for initialization purposes. We can see kind of, what's going on. Uh, in the future when we are working on this, I'm sure this video will be invaluable as far as understanding, how to set initial action maps. But yep. Okay, time manager, real simple. Step into that. Step over that. So if you want to see the time manager, we can look at it. I think it's used a whole bunch in this application. So yeah, platform timer, go to definition. So these are just overridden. It's you see get elapsed milliseconds reset. I guess this is just a timer, cross-platform timer mechanism that allows for analyzing, I guess, runtime. Maybe I guess I don't know. Okay, go back. So this is where it starts the input manager. The input manager is a global, I believe. Yeah. So within that namespace, it just calls instance, which gets a pointer. So it's the pointer that. So it's basically a function pointer in a sense. So it gets that. It starts it. I wonder if we can step into that. Yeah, we can. So the singleton has already been created. Let's step till return. Step again. Okay, so the start is just a notify request. It's just notifying that there's a timer starting. Sampler, what's this sampler all about? Okay, so I guess this is just for screenshots, maybe? Sampling allows per frame snapshots of specific values to be logged. For each value that you want to have sampled, you define a sampling key and then simply call the sample function at an appropriate place. If you want to sample the same value multiple times within a single frame, simply register several keys for it. Okay. Hmm. I have no real background in multimedia, so a lot of these terminologies are kind of foreign to me. Sample. Okay, I guess it is what it says it is. Were frames, snapshots of specific values. Interesting. Okay, let's step. So here's where it's initialized. Sampler frequency. Let's step over. We already analyzed that. Step into. Where are we? T signal. Okay, step till return. Okay. So flag static. I wonder what that does. Okay, hold on. Let's go into here. We want to look at the allocator. So flag static. Step. Step over. Step over. So 32. Hmm. Step. So I guess it might do its own heap management. Kind of weird. Hmm. Yeah, sorry, I was looking at this. This is a security mechanism. Like, I guess it has guard chunks or guard tokens between keys in the heap list. Okay. Interesting. So, long story short, this is what happens. Creates a global map, registers the object that's the global action map, stores the element you created within this main loop here as the global map. Since this is the since the object is never freed, it's used globally within the sim subsystem. Then it creates a time manager, creates a time event, starts the input manager, which is a function pointer or at least a macro kind of version almost. Um, of the input event manager. I guess there's only one supposed to be, maybe. I'm not sure. Then it starts a sampler, calls the initialization routine, which registers a console variable, I believe. Ooh, sorry, I shouldn't have stepped. Um, I guess it hooks in for UDP notification. And then it flags all of the current allocations to be static memory, I guess. So everything that was allocated thus far within its memory manager is considered a static value. Something that shouldn't be changed, I suppose. But yeah, if we step over one more time, we'll be back in the main loop. Here you can see the initialization was done, and now it's about to handle the command line. After it handles the command line, it will consider the full initialization completed, and it will return back and start the engine, I believe. But yeah, I'm going to conclude this video here. Once again, these videos are for my purposes only. If you use them and enjoy them, great. Because I'm learning this, there might be errors in it. I'm not sure. But I figured it would be useful to document the process of learning anyway. That's it. Stopping the video.